Conductor are those materials which can easily pass the current. These are consist of single elements such as copper, silver, gold, and aluminium. And these have many free electrons. Such electrons can move in a same direction or causes the current or make up of current. Now the insulator are those materials which have in compounds. Insulator are basically compound materials and such as wood, glass, and diamonds. And these materials have tightly bound their valence electrons, and only a few electrons can be isolated. So the electricity cannot pass through the insulator. Now the semiconductor are between conductor and insulator. In pure form, it is not a good conductor or not a good insulator. The most common semiconductor are silicon, germanium, and carbon. We are used the compound of the semiconductor like gallium arsenide are commonly in use. Now the intrinsic semiconductor are those which are in pure form, and extrinsic semiconductor are those which are in impure form, or some impurity can be added into the pure semiconductors. Then this extrinsic semiconductor will be formed. Now we discuss the energy band theory. Now in energy band theory, we discussed the valence band, free electron, conduction band. Valence band are those band when the valence electron have moved in these orbits, or the energy levels of the valence electron is known as in valence band. And when the electrons move from valence band to become a free electrons, and where the free electron move is known as the conduction band. In this band the electron can move easily and not tightly bound, and band is caused for the passing the electricity. The energy gap is that the valence band and conduction band. The gap between valence band and conduction band is called energy gap, and in conductor this is called forbidden energy gap. There are the three diagram of insulator, semiconductor, and conductors. In the insulator, valence band and this is the conduction band. The energy gap is very large, and there is no free electron can jump from valence band to the conduction band. So the insulator do not pass any electricity. On the other hand, the conductor, the valence band and conduction band are overlap. This means then the valence electron can easily move to the conduction band and cause easily the electricity pass can easily pass the electricity in conduction bands. On the semiconductor, we see that the valence band and conduction bands, and the energy gap is narrow means normal. It can be allowed some electrons from valence band to the conduction band. And it also explained that in germanium the energy gap has 0.7 electron volt, and in silicon in order 1.1 electron volt. And 0K semiconductor have behave like an insulator. That means it do not allow any valence electron jump to the conduction band. Now we discuss the atomic structure of silicon and germanium. Both have 4 valence electrons outside of the valence shell. While the silicon atom has higher ionization energy as compared to the germanium atoms. As germanium atom has a large number of electrons and their outermost shell has low ionization energy as compared to the silicon, so it can unstable at high temperatures. Now we discuss the covalent bond between the semiconductor materials. In this material, the silicon crystal look like that structure. Each atom of the silicon consists of four adjacent silicon atoms, and each have paired with the one other silicon atom and make their outermost shell to be 8 electrons. These electron is by sharing with one another, and these bonding are called the covalent bond. This is the intrinsic crystal of the silicon atoms. Now this is look like that, the lattice of the silicon crystal. Now we discuss about the conduction in semiconductors. This is the structure of silicon crystal. Intrinsic silicon crystals. The valence band consists of 4 valence electrons, which can be jumped into the conduction band and cause for the electricity. These electricity causes due to the electron or holes. In intrinsic semiconductor or silicon crystals, when heat energy give to the crystals, the electron move from valence band to jump to the conduction bands, and these free electrons are called conduction electrons. Next, as the electron move to the conduction band and leave behind a hole, these electron hole pair causes the electricity, and there we explain the electron hole pair. Next, the diagram showed that when we apply the heat energy to the silicon crystals, the electron can be jumped to the nearby hole, and the whole process is randomly continued. When we applied the voltage across these silicon crystals, we see that all the electron can move in a same directions and causes for the electron current. On the other hand, the hole pair is created as the electron move from left to right, the hole move from right to left, and the hole is also listed that the contribution of the electricity of the current. Now we discuss about the electric properties of the semiconductor, and then we discuss the Hall effects. These are the properties like conductivity, and we can find from conductivity from them, and intrinsic concentrations we can find from there. Energy gap, what is the energy gap, we also discuss it. Mobility, Hall effects. Now Hall effect can be carried out by finding these materials N type or P type. In Hall effects, the electric current I and electric field E and magnetic field B are all perpendicular to each other, and this phenomena is known as Hall effects. You can read it in mathematical forms and explain all the things that how to find rho and Hall effect coefficients and so on so on. I am going to teach you about n-type and p-type semiconductor and doping. Doping is a small impurity which can be added into the intrinsic semiconductors and become extrinsic. There are two types of characteristics, n-type and p-type. N-type semiconductor can be made by pentavalent impurity added into the semiconductor crystals, and like arsine, arsenic, phosphorus, bismuth, antimony. They are all have outermost electrons 5. So 4 electrons make the sharing with silicon atoms, and 1 electron have free to move anywhere. Due to these free electrons, the material is called n-type semiconductors, and the whole crystal have electrical neutral because the total number of electrons are equal to the total number of protons. Due to this pentavalent atom, this atom is called the donor atoms, and the majority charge carrier is electrons and minority charge carriers as a whole. On the other hand, p-type materials, when trivalent impurity can be added into the silicon atoms like boron, iridium, gallium, they have their outermost shell 3 electrons, and these 3 electron makes the share with the silicon nearest silicon atoms, and one unpaired electron hole is formed, and this hole is used for passing the electricity. There the majority charge carrier is hole and minority charge carrier is electron. Now we discuss the diode. When a piece of intrinsic silicon crystals can be doped from one side in p-type material, on the other side is n-type materials, and recombined and make the p-n junctions. In p-type materials, a hole in majority charge carrier, in n-type material the electron in minority charge carrier, and they can move from p-n junctions on the opposite. This diagram shows the electron can be moved from p-n junction and go to the p region, and the holes move from p-n junction and go to the n-type region and makes the depletion regions. Next, we discuss about the barrier potentials and what is the barrier. These barrier potential is caused for the field of force and called electric field, because when the oppositely charged electron and hole pair has recombined and makes the barrier of the potential. There he explained that the silicon atom has a barrier potential 0.7 volt, while the germanium has 0.3 volt.